Alright, CNT125, Routers and Routing Protocol Lab. We have, in the last part, we got our workstations in, we got them connected, we got them configured, and we even did a little bit of troubleshooting of what I'd be looking for and how it would fix maybe some errors or problems in my network. We are now going to move on to, now that the network's up and running, let's look at the routing table and also the routing update packets, if you will. So we're going to look at our routing protocol. Now that's on there and working, let's look at it. So let's go back into our console connection. I'm just going to pick on the Harrisburg side. And we want to issue the command show IP route. Actually, let me do show run again real quick and remind you, we have configured the RIP routing protocol. And the RIP routing protocol is going to communicate with other routers and use that communication to build the routing table. And the routing table is kind of like a mental map in your brain of where things are, where networks are. In this case, the router is like, where are these networks? So we want to, now that that's up and running, let's look at that routing table. So we're going to do a show IP route. That is the command to look at our routing table. Show IP route, show IP route. When I hit the enter key, I'm going to make this wider so it shows up a little bit better. The first thing we see is a key. We'll need that. Those little abbreviations are helpful to decipher the routing table. Down here is the actual routing table. Now, gateway of last resort is not set. That is fine. We have not set any kind of gateway address in here. So that's to be expected. We are focusing on this right here. These are the three networks that we have. We have the 10 network, the 172 network, and the 192 network. That is what's in our lab, if you will, our setup. And the router says, okay, I have learned about the 10 network. It is directly connected. That's what the C is. I have learned about the 192 network. It's directly connected. That's what the C is. And if I keep reading those lines, this is okay. This 10 network is directly connected on the Fast Ethernet 01 port. And if I slide this over here, I'm going to hold my pointer over the router. It shows up a little abbreviation here. And if I look, I see Fast Ethernet 01. It says the 10 network. Fast Ethernet 00 says the 192 network. So the routing table says, okay, this 10 network is directly connected on this port. And it also says the 192 network is directly connected off the Fast Ethernet 00 port. So if data comes in, if a packet of data comes into the router and the destination address is 192.168.10.50, the router goes, ooh, I know where that is. I'm going to pass it out the 00 port, and away it goes. And the same would be true for the 10.0.0.0. If there's something comes in for 10.0.0.50, it knows where that is. It'll pass it out the Fast Ethernet 01 port, and away it goes. Now, the third network in here, if I look closely, it was learned through, well, R tells me RIP. That's what the key up here says, RIP. It says this 172.16 network, I can get to, if I go out the Fast Ethernet 01 port, and I go to this IP, I can get to that network. Well, if I look at it, the 172 network's over here. So it goes, okay, if I go out the Fast Ethernet 01 port to this IP, which is 10.0.0.2, I can get to this network. And it learned this from this router. This router told it that, hey, this 172 network is over here. So it has learned that through RIP, put it in this table and said the 172 network is over there. If I go out this port to this IP, I will get there. And then the last little part here is also useful. This one says is basically one router away, one network, one hop away. And it learned it through RIP, so it assigned an administrative distance of 120. If you remember when we talked administrative distance, each routing protocol has an associated administrative distance associated with it. So anything learned through RIP gets assigned a 120, and that number ranges from 0 to 255. So 120 is kind of in the middle. Yeah, RIP information is kind of, I'm doing my hand side to side here, like so-so. The information is kind of so-so. So it gets assigned a 120 of like, okay, it's okay information. If I learn something better, this would get booted. But if not, it's going to keep this, and it's going to let me know the information is kind of meh. Okay? So there is my RIP routing table. Now, while I'm here, I am actually going to save that. So I'm going to start a text file here. I'm going to open my text editor, my notepad. I'll do 125. I'll do routers lab, and I'm going to put a note in here that this is my RIP routing table. And I'm going to copy this. Oh my goodness, there we go. I'm going to copy this. Let me get my pointer here. There we go. I'm going to highlight. I'll highlight this whole thing. I'm going to do a right click, copy. And I'm going to come over here and I'm going to do a paste. Control V, paste. And I'm going to save this as something like, and I'm going to save it to I have a folder started for my 125 routers lab. There we go. I'll put it right there. And I'll call this like 125 RIP routing table, something of that nature. .txt, leave the txt on there. All right, so I want to save that. I want to save that so I have it. Now, while I'm here, I'm also going to, this was my Harrisburg router. Let's go over to the Philadelphia router terminal. And let's do the same thing. Let's do enable. Let's do show run. Let's come down here. Here is my RIP routing protocol config that I did earlier. So it is now running RIP. And let's do a show IP route on this guy. And this is going to be almost identical. Almost. This router is a newer router model. The 4300s are newer than the 2811s. And therefore, the information I get in my routing table is a little bit better. It's the same routing table, I just get a little bit more information. What I'm going to see is I still see the 10 network, I still see the 172 network, and I still see the 192 network. So all three networks are still there. I just get a little bit extra information on this routing table. If I start here, I'm going to group all the 10 network together. It says, okay, I've learned about the 10 network. The 10 network is directly connected. That's the first line. And then it also shows you that, hey, L is for loopback. It's saying, hey, the address on this interface is 10002. It's actually telling me the address of that interface. That's why there's a /32. /32 says basically right here is /8 is a subnet mask of 255.0.0.0. The /32 is indicating, hey, I'm showing all 32 bits of this, not just the network number. I'm showing all 32 bits. So this is actually the IP address of that interface. If I look at the 172, I'll see a similar format. Okay, that network is directly connected, and by the way, the IP address is 172.16.0.1. And then over here, we see RIP. It learned the 192.168.10.0 network. I can get there via this port, going to this IP, and it's one router away. Okay, so I see an almost identical routing table. I'm just getting the additional info of the IP address on that interface. So if I want to, I can copy this one. I don't need you to, but you can copy this one while I'm here. Come on. You're going to be... You're being a little pesky. There we go. Right click on this guy, copy, and I'll go to my text file again, and I'll paste it in. I don't need both, but I'll just put both while I'm here. Okay, so that is looking at our routing protocol and our routing protocol table. Now let's look at some packets. So we're going to go to the closet and we're going to add our packet sniffer in. So let me close a couple things here. I'll save my config so far. Let's go to the physical, and we're going to go to the Harrisburg wiring closet, which I'm actually already there. So I'm going to go to the Harrisburg wiring closet. I'm going to add in, I need to add a sniffer and a hub. So I need end devices, I need a sniffer. It's over here on end devices. I'm going to put that in my rack. And then I also need, under network equipment, I need a hub. So packet tracer hub, and I'll put that in the rack here too. Fine, all right. Get up there. There we go. Okay. So we need to remove the connection between the router and switch. So I'm going to do that. That's this connection right there. I'm going to remove that connection. And I now need to connect the router to the hub. Oops. So I need the router to the hub straight through. So we're going to go router port into the hub. And now I need the switch to the hub. So we're going to go switch right here to the hub. And I now need a crossover to go from the sniffer, and I need sniffer port 0 to the hub. So I need to make sure I get the port 0 into the hub. It doesn't matter what port. And that now has a hub in and a sniffer. So the hub's going to repeat everything to the sniffer so we see all the traffic. If I go back to the logical, yes, it might look a little weird. Let's move our hub and our sniffer up here. Come on. This thing likes to fight with you a little bit. Move the sniffer up there. You can move it up here and make it look a little nicer if you want to. There we go. That's good. So any traffic moving through the network now, the sniffer is going to catch. So let's open the sniffer. And we want to make sure port 0 is selected. We're going to clear all the filters. Actually, we want to do show none. Okay. We are going to go to edit filters, and we want to just see RIP on IP4. And we're going to clear all the packets that have been captured. We're going to let that run for like a minute, and we want to look at one of the RIP packets. So we'll let that run, and we're going to look for a RIP packet to come in here, and we're going to open that and take a peek. And what we really want to see is we want to take note of the source and destination IP address in this RIP packet. We want to see who generated it and where's it going. So there's a RIP packet. Let's open this guy up, and I want to see where did this come from and where is it going. So here's my Ethernet header. Here's my IP header. The source IP is 10.1. Well, that's my router. And the destination address is 255.255.255. It is a flat-out broadcast. So RIP packets, the router's generating, and it's going to broadcast to everybody. Yes, that's how RIP works. It broadcasts its, and if I keep going, down here it's its routing table. It broadcasts its routing table to basically all neighbors. And those neighbors pick it up, add that information to their table, and then they broadcast it on. Which is one of the reasons we don't use RIP anymore. All right. Now, make note of this. You need these for review questions. You need those 2 tidbits for the review questions, so make sure you make note of that. All right. That is our RIP routing protocol. In the next part, we're going to come back and take RIP off, and we're going to put OSPF on and look at OSPF packets.